lightning. So before I get started, I want to give a couple of warnings and reminders. Reminder number one, please keep the red part of the carpet clear, including the stairs. And the warning, warning! This presentation will include bright flashes and loud noises. So if you do not like bright flashes and loud noises, I am telling you right now, there will be bright flashes and loud noises. Or perhaps you don't know whether or not you like that sort of thing. Or more importantly, the young person on your lap or immediately next to you doesn't know yet. And then they decide they don't. That's fine. Take a look around right now and figure out which way you want to flee if you need to leave. If you're sitting right in front of me, over to your right, there's a door to the Blue Wing. At the back of the theater, behind me, between the two red houses, there is a door that goes to the corridor that goes to the Blue Wing. Interrupting the balconies, of course, right behind you is a door to the Blue Wing, unless you want to sneak over to the computer place and watch from behind the safety glass. Now, if someone is behind you and they're trying to get out, let them out. They don't want to be here. But if you leave, you are going to miss seeing me entirely surrounded by metal being struck by lightning. So there's your choice. Now, with that out of the way, the first thing I want you to know about electricity is it's invisible and it's silent. You can't see it. You can't hear it. Which makes the warning I just gave either really, really bizarre or really, really intriguing. I hope it's the latter. Talking about electricity can be confusing, but all of that talk comes down to one thing: the electric force. The electric force is a natural, fundamental force. It is in everything. It is everywhere. It's like another force with which you are no doubt familiar, the force of gravity. But gravity is a one-way force. Gravity is a pulling force. The electric force is a two-way force. It pulls and it pushes. We talk about the electric force in terms of electric charge. And there are two kinds of electric charge, identified and named by Benjamin Franklin. There's positive charge and negative charge. Now these are opposites, and opposite charges attract. That's the pulling part of the force. But same charges, positive and positive, negative and negative, these will repel. That's the pushing part of the force. Now usually everything is balanced with equal amounts of positive and negative charge. But sometimes charge can get separated. It gets unbalanced. And to get back into balance, the result can be a bolt of lightning. Or you can use a machine. Now this machine, it's not even turned on. This is a small Van de Graaff generator. The Van de Graaff generator was designed and built by one Dr. Robert Van de Graaff of the Massachusetts Institute of Technology, just up the river from here. That was back in the early 1930s. He was exploring the insides of atoms. And the machine that he built back then is right behind me. That's it. That is the Van de Graaff generator. MIT didn't need it anymore, so they gave it to us. And we're very grateful because we use this machine to make lightning. See, inside the column right behind me, there are three large belts. And each belt is attached to a motor down in the basement. We turn the motors on. The belts spin around. We put charge on the belt, either positive charge or negative charge. The belts carry the charge up to the domes where the charge collects. It builds up. It's out of balance. And then it gets back into balance with bolt of lightning. You believe me?
Yes.
Yes? Okay, we're done. No. You can't believe me. That's not how science works. Science, you need evidence. You need proof of claims. This is not politics. If I say something's going to happen, I have to prove it is going to happen. So if I say something like, this machine makes bolts of lightning, you should demand evidence. You should say, prove it, Terry. Say that. All right, let's take a look downstairs. If you look up at the screens, you will see the 3 motors downstairs with the belts attached. I'll turn them on, and they'll start up one at a time. First the one on the right, then the one in the center, and finally the one on the left. Now, before I put the charge on the belt, I am going to protect my ears.
It's too dark in here.
This is what the bright flashes and loud noises. Starts now. So when you see me protecting my ears, you may want to protect your ears as well. Here comes the charge.
It's not working that on.
Did you like that? If you like that, stick around. They're going to get bigger, they're going to get brighter, and they're going to get louder. If you didn't like that, I'm sorry, they're going to get bigger, they're going to get brighter, and they're going to get louder. So that is how we do it with the machine. But what is going on inside of a cloud? Because obviously clouds do not contain 4-story tall mechanical devices. But something similar is happening in a cloud. Charge is getting separated. It's getting unbalanced. And then getting back into balance with a bolt of lightning. So how does charge get separated? Well, one way is when different materials come into contact with each other. This can separate charge. So what different materials are in a cloud? Not much. Water droplets, ice crystals, dust, and that's about it. But these things collide and bounce around and hit each other, and that's enough to separate charge, making it unbalanced. Now, I want to show you how this works. I want to show you how different materials coming into contact can separate charge, but I need a volunteer for this part. I need a certain kind of volunteer. Preferably one who's very close to me, so I don't have to jump over the railing. This person right there, give me my friend. Stand in that box, please. So stand. Sorry. What's your name? Grace, thank you very much for volunteering. Grace, are all of your charges right now balanced? Well, they are. Otherwise, you'd explode. Although having said that, Grace, I would like your permission to unbalance some of your charges. You won't explode. I'm going to use a very sophisticated, advanced technological tool on your person to separate charge. It's a pneumatically enhanced adjustable sphere. Is that all right? Okay, good. Let me get my pneumatically enhanced adjustable sphere. And here it is. You have to use the big words. That's how you get grand money. All right, let's get Grace up on the screen so everyone can see her, because I'm under the impression that this balloon is made of different material than Grace's hair. Grace, is your hair made of rubber? Good, because this balloon is not made of keratin. So that's 2 different materials. We'll bring them into contact with each other and separate charge. Now, Grace says her charges are balanced with equal amounts of positive and negative charge. The balloon is an excellent material for attracting negative charge. So I'm going to take some negative charge from her hair.